Chapter 6, Section 3, Data Visualization for Univariate Analysis, Part 3. In the previous video, we talked about histogram as a way to visualize the distribution of a continuous variable. As the third section, let me show you other methods for univariate analysis of continuous variables. This section focuses on box plot and a line plot. A box plot can visualize the distribution and representative values of a continuous variable. A line plot is useful to visualize a time series trend of a variable. A box plot is a plot that represents the distribution of data by box and whiskers. It shows the range of the distribution and where the data points are concentrated. Using a box plot is advantageous in that it can show the basic metrics like median, quartiles, and IQR. It also shows outliers. And from a box plot, we can see whether the data is symmetrical or skewed. Let's see the structure of a box plot. The square with a horizontal line in the middle is called a box. The horizontal line in the middle of the box represents the median, that is, the second quartile. And the lower end and the upper end of the box represent the first and the third quartile, respectively. So, the height of the box represents IQR. The two vertically extending solid lines are called whiskers. The upper end and the lower end of the whisker represent the maximum value and the minimum value. So, the box plot visually shows the range of the data and the median. But it does not show the mean and the mode. A box plot also shows the skewness. We can see the skewness of data by looking at these intervals. By definition, quartiles divide the data by the number of data points. So, there are the same number of data points included in each interval. So, each interval indicates that 25% of the data points lie within each interval. So, the height of the box represents the distribution of the 50% of the data points. That is, the 50% of the data points lies within the box. And since the same number of data points are included in each interval, a box plot can show how densely the data is distributed within each interval. And the longer the interval is, the data points are distributed more sparsely. So, in this example, the upper interval is shorter than the lower interval. It means that the data points are more densely distributed between the first and the second quartile than between the second and the third quartile. The length of the whiskers also represents data skewness. Here, we have two box plots. One is for dataset A, and another is for dataset B. Suppose these two datasets have the same number of observations. As we can see, the upper whisker is much longer in the box plot for dataset A. It means that the interval between the third quartile and the maximum is longer for dataset A than dataset B. It indicates that, compared to in dataset B, in dataset A, the data is more sparsely distributed between the third quartile and the maximum. In other words, between the third quartile and the maximum, the data is more densely distributed in dataset A than in dataset B. Next, let's see how to display outliers in a box plot. Outliers are extremely large or small values. In the previous example, the upper and the lower end of the whiskers are maximum and minimum values. So, outliers are included somewhere in the whiskers. There is another way to depict a box plot. We can depict a box plot that displays outliers separated from the whiskers like this example. By doing so, we can identify outliers clearly. To plot outliers in this way, we need to set quantitative criteria to define outliers. As we saw in the previous chapter, there are no one best way and the only way to define outliers. But commonly, outliers are defined by using quartiles and IQR. That is, values greater than 1.5 times IQR away from the upper or lower end of the box can be regarded as outliers. If we use a time series data, a good option for visualizing is a line plot. For example, when we plot the longitudinal stock price fluctuations or monthly records of temperature, a line plot is useful to analyze and visualize a time series trend. The horizontal axis represents the timeline, and the vertical axis represents the value. When we create a line plot for time series data, we should be careful not to set the period too short. Let's look at this example. It is a line plot that depicts the longitudinal stock price fluctuations of a company. It shows the stock price from the year 2019 to 2020. According to this chart, the stock price seems to be on a downward trend. But let's look at this chart. This line plot is the same company's stock price, but it records the data with a longer period, from 2015 to 2020. The stock price of this company seems to be on an upward trend. In this way, if we take a too short period, we will end up in looking at the trees and not looking at the forest. Thank you for watching. Please thumbs up and subscribe to my channel.